Okay, today I'm going to talk about the atomic structure worksheet that you will be working on. On the very first page, you notice you have a big table that says element name, element symbol, atomic mass, atomic number, neutrons, protons, and electrons. What I want you to remember are a few key things. First off, the atomic number is equal to the number of protons. That is key information. So those two columns should be the same. Number of protons is equal to the number of electrons, because in a neutral atom, your number of positive charges, or protons, has to equal your number of negative charges, your electrons. Okay? Then, the third thing I want you to know is atomic mass is equal to the number of protons and number of neutrons. Okay? So, to find the number of neutrons, you take atomic mass minus atomic number. Okay? So mass minus number equals neutrons. Running out of board. Okay? So that's how you're going to fill those in. So if we look at that first one on your chart, you're given the symbol indium. Look on the periodic table. If you have your textbook, you can go to that 2-page spread in the middle of chapter 3. You find IN, and that is indium. Okay, so on that one spot, you're going to type in indium. Then you're going to go and look and find the number of the atomic mass, rounded to a whole number. Okay, and so when I look on my periodic table, trying to find indium. Indium's atomic number is 49. So under the atomic number column, I'm going to write 49. I find indium, and its atomic mass is 114.8. So I'm going to round that up to 115. Okay? So then I'm going to go, well, my number of neutrons, mass minus atomic number. And if I use my calculator, I'm going to plug in 115. Got two things on my brain. 115 minus 49. And I get 66. So neutrons is 66. All right, I told you earlier that the number of protons is the same as the atomic number. So protons is going to be 49. The number of electrons is going to be 49 as well. So when I go through this, I'm going to fill in the rest of the chart. Now the second one, I just gave you the number of neutrons. I gave you 5, nothing else. You are going to have to go through the old guess and check way of math and find the difference between your protons, that's your atomic number, and your mass. So if I start with hydrogen, because it's number 1, well, 1 is the mass, 1 is the number, the difference is 0, there's no neutrons. I can't go there. I can skip helium because that's 2 and 4. 4 minus 2 is 2. Lithium, 6.9. Well, that rounds up to 7, but the atomic number is 3, which makes it the number 4. Beryllium, it's got 9 as the atomic mass. The atomic number is 4. 9 minus 4 is 5. So that tells me that beryllium is number 2. So I'll fill in all of my parts of the chart with that information. You're going to get all the way down. The rest is pretty easy until you get to the second to the bottom, which has another one of those neutrons only. It's 125. Guess and check again. So write yourself a note right now, or else go back to this recording. I'm going to give you a clue and look on the right-hand side. There's multiples that have atomic mass, atomic number difference of 125. It's not all the same element though. All you need to do is find one. That's page 1. Now, if we look at page 2, let me flip to a new screen. Page 2, you're going to take those 12 atoms, 12 elements, and realize what the number of electrons are, the number of protons, and how to solve for the number of neutrons. Okay? What I recommend you do is next to each of those names, put the symbol. So hydrogen's the symbol H, sodium is Na, you got to start learning these. Iron is Fe, phosphorus is P, carbon is C, argon is Ar, you are gone, calcium is Ca, chlorine is Cl, scandium is Sc, nickel is Ni, fluorine is the letter F, remember it's not Fl like Florida, and oxygen is the letter O. You're going to fill in each of those. Use your periodic table. So if you go to the third page, you're going to notice you have the same 12 elements. Put the symbols next to those names again to help you out, because you're going to want to pull up that one special periodic table that I have that says orbitals next to it. What you're going to want to do is make Bohr models of each of these. Now, in this one, they just showed the number of protons on the inside. What I want you to do, if we look at sodium, in my nucleus, I'm going to put the symbol Na so I can remember. There are 11 protons. Okay, put a P with a little t next to it. That means positive charges. If I subtract my number of protons from my atomic mass on the other page, I notice my number of neutrons is 12. So in here, I want 12 with a little n next to it. Just like that. Then, if I look on the side of that box where sodium is, find the symbol Na, I'm going to notice that it's in the third period. There are 3 little numbers in a row, okay? In the first circle around, I'm going to have 2 dots. In my second circle around, I'm going to have 8 dots. At this point, just kind of do it like this. In the third circle around, okay, I'm going to have 1 dot, because that tells me there's 1 valence electron. You're going to want to do that for all of those. So in each one, in the nucleus, number of protons, number of neutrons, and the symbol. Okay? Then draw your number of orbitals and put the number from inside that periodic table so you don't have to figure out how many are on each orbital. Got it? That's your atomic structure worksheet directions. Any questions, please email me. If you're in class, talk to me, but have a great day.